Hi, my name is Evelyn. We are here to teach. I'm here to teach potential energy. Potential energy. Let's start with the definition of potential energy. An object can store, for example, storing energy position. An object can store, for example, is the storing energy position. This stored energy position stored as the result of the position. Assuming the conjure, that is, when not drawn, there is no energy. So let's talk about gravitational potential energy. Gravitational potential energy. There are two examples above illustrate the forms of potential energy. So, potential energy, a ball, and it says potential energy is discussed in the course gravitational potential and elastic potential energy. So we have two types of potential energy, which is the gravitational potential energy and elastic potential energy. Gravitational potential energy is the energy stored in the object as a result of its vertical position or height. The energy it stores due to its vertical position or height. The gravitational potential energy of the vast ball of a demolition machine is depend on two variables: the mass of the ball and the height to which it is raised. There is a direct relationship between gravitational potential energy and the mass of an object. More massive objects have greater gravitational potential energy. There is also a direct relation between gravitational energy and the height of an object. The higher that an object is elevated, the greater the gravitational energy and the height of an object. The higher the object is elevated, the greater the gravitational potential energy. These relationships are expressed by the following equation. So, uh, the higher that the object is elevated, the greater the gravitational potential energy. So this is how. So let me write it here. So the higher that an object is elevated, yeah, the greater the gravitational potential energy. So this is how it represents an equation. PE, which is the gravitational, equals to mass times gravity times height, which is PE equals to M times G times H. So that means potential energy mass times gravity times height. And M represents mass of an object. H represents the height of an object, and the G represents gravitational field strength, which is 9.9 Earth. And here, to determine the gravitational energy of an object, a zero height position must first be arbitrarily assigned. Typically, the ground of the considered to be a position of zero height, but this is merely an attribute assigned position that most people agree upon. Since many of our labs are done on tabletops, it is often customary to assign the tabletop to be zero height position. Again, it is mainly attribute. If the tabletop is the zero position, then the potential energy of an object is based upon the height relative to the tabletop. For example, a bottom bomb swing to the form above the tabletop have a potential energy that can be measured based on its height above the tabletop. By measuring the mass of the bulb and the height of the bulb above the tabletop, the potential energy of the bulb can be determined. Gravitational potential energy of an object is directly proportional to the height above the zero position. A doubling of the height will result in a doubling of a gravitational potential energy. A tripling of a height will result in a tripling of a gravitational energy. Use the, the principle of determining the bank in the following diagram. Knowing the potential energy at the top of all the platform is 50 joules. What is the potential energy at the other position shown on the stair steps and the incline? So here, example. Um, uh-huh, 50 joules. So let's come to elastic energy. Um, Elastic potential energy. The second form of potential energy we will discuss is elastic energy. Elastic energy is the energy stored in elastic material as the result of their scratching or compressing. Elastic energy can be stored in rubber bandage cords, crimping springs, an arrow drawn into a bow, etc. The amount of elastic energy stored in such a device is related to the amount of stretch of the device. The more stretch, the more stored energy. Strings, springs are a special instance of the device that can store energy potential due to either compression or stretching. A force is required to compress a spring. The more compression there is, the more force that is required to compress it further. For a certain spring, the amount of force is direct potential to the amount of stretch or compression. The constant of potentiality is known as the spring constant. So the spring constant is written as an equation as F is K times X. So such springs are said to knowledge hook law. If a spring is not stretched or compressed, then there is no elastic potential energy stored in it. The spring is said to be at its equilibrium position. The equilibrium position is the position that the spring naturally assumes when there is no force applied to it. In terms of potential energy, the equilibrium position could be called the zero potential energy position. There is a special equation for springs that relate the amount of elastic potential energy to the amount of stretch, that is compression, and the spring constant. The equation is the equation is P E, that is the spring, is equals to 1 over 2 times K times X squared, where K is the spring constant, X amount of compression relative to the equilibrium position. To summarize everything, potential energy is the energy that is stored in an object due to the position relative to some zero position. An object possesses gravitational potential energy if it is positioned at a height above or below the zero height. An object composes elastic energy is it at a position on an elastic medium and other compressing position. Let's have some example. A cart is loaded with a brake and pulled at the inclined position of a